This video is on translating between words and algebraic expressions, and it's lesson 17 in your book. This is a really important lesson because anytime we do a word problem, we are translating between words and algebraic expressions to help us find the solution. There are certain words that are keywords that tell us that we are going to use addition in our algebraic expression, and those are words like plus, and, total, and sum. There are also some phrases and expressions that signify that we will use addition in a problem. Those are expressions like added to, greater than, more than, increased by, and sum of. There are also some words that we use in verbal expressions or written expressions to express subtraction. These are words like minus, from, or less. And some phrases and expressions are difference between, difference is a big one, less than, fewer than, decreased by, and take away. Anytime we're looking for the difference between two numbers, we subtract them. Obviously we know less means to take away, to subtract, and fewer and decreased. We also have words that tell us that we're dealing with multiplication. These are words like times, product, at, twice, each, double, triple, quadruple, and of. Whenever we take half of something, we are multiplying it by a half. Or if we take 3/4 of a number, we're multiplying it by 3/4. Some of these words are specific, like twice tells us to multiply by 2. Also, double tells us to multiply by 2. Triple would signify multiplying by 3, and quadruple would signify multiplying by 4. And finally, we have words to express division. These are words like quotient or per, as in miles per hour signifies that we have taken a total number of miles and divided it by a total number of hours. And some phrases and expressions that tell us we're using division are quotient of and goes into. Quotient of will be followed by two numbers. So if you say the quotient of 6 and 3, that means you take the first one, 6, and divide it by 3. And then, of course, goes into. Here are some examples, and these need to be in your notes, in your notebook. So we're going to translate these expressions, algebraic expressions, into words, and we want to be able to write them multiple ways. So we're going to write two different ways for each of these. Okay, so here we have a variable. We have m. Now, typically when we have a variable, we say a number. So we're going to start with a number. Then we have a symbol. We have addition. So we want to choose one of those words that means addition to put between m and 7. So we can say a number possibly added to. And then finally, that last number that we have, 7. So we could say a number added to 7. Another possibility we could use is a number greater than 7. You could also say a number more than 7, the sum of a number and 7, or you could say the total of m and 7. There's lots and lots and lots of different ways to translate this into words. Now the second example is y, a variable, minus 9. So we're going to have to use words that deal with subtraction. Now difference is a big one, so a possible way to write this would be the difference of, or difference between, and whenever we use difference, it comes before the two numbers. So we would say the difference between. Now you could either say y or you could say a number. I'm going to use a number here. The difference between a number and 9. Now another way you could write that is to use fewer than. Now when you use fewer than, the last number needs to come first. So I would say 9 fewer than a number. we do subtraction, we really need to watch out for that, because when we use fewer than, the number that we're subtracting always comes before the number we are subtracting from. That's why it's 9 fewer than a number. And this last one on this page is 5h, and when they're written next to each other, that signifies multiplication. So we are multiplying 5 and h, or 5 and some number. So we need to use some of those expressions that signify multiplication. Now, one way to do this would be to use the word product. So we could say the product of 5 and a number or another way we could say this is 5 multiplied by a number, 5 times a number. We'll go with 5 multiplied by a number. And keep in mind when you're doing these that there are lots of different but also correct ways to write these. Alright, here's another couple of examples. Again, these need to be in your notebook. We want to translate these expressions into words and write them at least 2 different ways. So here we've got x divided by 3. So x stands for some number. So I'm going to start with a number. Now I can say divided by 3. That's one way I could write that. Another keyword that we have for division is quotient. So I could say, just like we use product first before, we're going to use quotient first here. The quotient of a number and 3. So those are 2 different ways to write that one. Now here, we don't have any variables, but that's okay. We do, however, have 2 different operations. We have multiplication here, and we also have subtraction here. So we want to write this 2 different ways. Now, one way we could write it is we could start with this end first. So I could say half of 18. That signifies our multiplication right here. And then since I'm subtracting it from 27, I could say fewer than or less than 27. Now if I wanted to start with 27 instead, I could say 27 minus, and then maybe a different way to write 1/2 times 18 would be the product of 1/2 and 18. Alright, so there's 2 different ways to write that one. Alright, now let's go the other way. Now let's change some words into some expressions. Now usually there's only one way to write these, so we're only going to go for one. I want to change y increased by 12 into an expression, an algebraic expression. So here the 2 things I'm doing the operation to are y and 12. And this phrase right here, increased by, is one of our phrases that tells us that we're going to have to add. So y increased by 12 would be written in an algebraic expression as y plus 12. Here we have the product of x and 4. Product of is one of those keywords that tells us we need to multiply, and then this tells us what we are multiplying. We're multiplying x and 4. So we can write that as 4x, or 4 times x. This next part says 8, that's one of our numbers, less than, that's something that tells us we're going to have to subtract. The quotient of, that tells us there's going to be some division. And here's what we're dividing, m and 15. So we're going to have subtraction and division in our expression. We're also going to have the numbers 8 and 15 and the variable m. Now, 8 less than means that we are subtracting 8 at the end of the problem, because it's 8 less than, so we have to subtract 8. It wouldn't be 8 minus. Now this tells us we're dividing two things, m and 15. So we would have m divided by 15. So that would be the quotient of m and 15 less than 8, or 8 less than the quotient of m and 15, sorry. Here we have James is 6 years younger than Lydia. Write the expression that shows how old James is. Okay, so we have two unknowns here. We have James's age and we have Lydia's age. Now I'm going to write James's age as J and Lydia's age as L. Okay, is tells me that I'm going to have an equals, because equals is are the same as. Here's a 6. I'm going to need that in my expression. And he's 6 years younger than. Younger than tells me that I'm going to need to subtract. Alright, so James is, that tells me I need J equals 6 years younger than. Now that's the same as fewer than or less than, so I'm subtracting 6 from the end of my problem. Younger than Lydia, so Lydia is what I'm subtracting from. James is Lydia's age minus 6. That's how we would write that expression. Alright, and this is our last example. This needs to be in your notebook as well. And these up here, they also need to be in your notebook, so make sure you get those written down. This says, Jane is saving money to buy a car. She has X dollars saved and is saving Y dollars per week. Write an algebraic expression to represent the total amount of money she will have saved after 52 weeks. Alright, so here's our information. This is how much she has saved already. She is saving Y dollars per week. Now per tells us we're going to have to multiply dollars times weeks. And this says we want to write an expression about the amount of money she'll have after 52 weeks. So we know we need to multiply dollars times weeks. So we have Y dollars times how many weeks we have, which is 52. That's how much she's currently saving. Now, she has X dollars already saved, and we want to find the total amount of money she's saving. So we're going to have to add X amount of dollars. This is how much she already is saving. This is how much she's saving times how many weeks she'll be saving it. And so our expression, if we rewrite it algebraically correctly, would be 52Y plus X.